pattern says, so if you have this triangle ABC, and A is given as, C is given as 40 degrees, B, so the side opposite angle B is 36, and C, the side opposite angle C is 27. And so if you look at the pattern of information that's provided, it's SSA. So SSA tells you you're using law of sines. And the SSA pattern isn't a congruence pattern, so that means you may have one triangle, you may have two. In order to determine that, you look at the side opposite the given angle. If it's smaller than the other given side, which it is in this case, then it is possible for there to be a second triangle, the one that's now identified in red. So we're going to be looking at two different triangles here. All right, so the first one we can find angle A, angle B, and side A. Okay, so the first thing we can do is find angle B. So if we take the sine of B over the side opposite at 36, set it equal to the known ratio. The known ratio we have is the sine of 40 degrees and the side opposite that. And just solve. Now keep in mind that this is one of those cases where it won't solve for an angle inside of a trig ratio for you. So you have to let x represent this whole sine ratio. And then we'll solve it and calculate it by hand. So if we use the F2 algebra tab, type in our equation, x divided by 36, set that equal to the sine of 40 divided by 27. I'll put a decimal in there, so my answer is going to be in decimal form. Okay, I expect my answer to be something between -1 and 1, since it's a sine ratio. And this is consistent with what I would expect. And so I can actually solve for the angle B by taking the inverse sine of that ratio. So if I take the inverse sine, and the way I'm going to do it is I'm just going to call it of x, use my width key, and then highlight what x is equal to. I get my angle measure to be 58.99 approximately, or 59.0. I think I have it rounded to the nearest tenth. Okay, so B is 59.0. I can solve for angle A now by taking the difference of the two known angles from 180. So 180 minus that 40 degree given angle minus this angle that we just found. And that gives us 81 degrees for angle A. Once you have those two, you can now find this length A opposite that by setting up another law of sines. You can take our unknown A divided by the sine of the angle opposite that, which we just found to be 81. Set it equal to the known ratio. So it's the same ratio that I have, sine, or 27 over the sine of 40. I only inverted my fraction because I'm solving for the different variable. I'm solving for the side length now. And so this is already set up in such a way that it'll calculate. So I'm going to use the x instead of an a. As I enter it, but I get x divided by the sine of this 81 degree angle, set it equal to my known ratio, which is 27 divided by the sine of 40. I already have decimals in there, so I just want to solve for x. Okay, and this gives me my actual length, 41.5. Once I have my first set of measures, I can then identify B2 and A2 up here. This will give me a second set of angle and side. And then my side opposite, angle A, will also need to be established. So the way that I find that is use the idea that this is an isosceles triangle. The triangle created by A, B, and B2 is an isosceles triangle, which means these two base angles are going to be the same. So this one is also 59. And if that's 59, then that leaves an angle of the supplement right here. So if I take 180 minus the angle of 59 degrees that I just found earlier, I get my new angle B to equal 121.0. So that's this angle. So now if I add that and 140 together and remove it from the 180, the total sum of the angles in triangle A2B2C. If I take 180 minus the angle I just found, minus the 40 degrees that was given, I'm left with about, again, 19 degrees for my A2 value. And so my final step to find A2 is to use the same proportion I used down here. A2 over the sine of the angle opposite it, which is now 19.0 degrees. Set that equal to my known ratio, 27 over the sine of 40. And I'm going to solve this for A2. So as I enter that on the calculator, I'll just use an x. The x divided by the sine of this angle, 19. Set it equal to my known ratio, 27 divided by the sine of 40. Close it off and solve for x. It'll give me my actual value, which is 13.7 approximately. And so those would be my measures.